Alrighty, welcome everybody to our Cisco lab, and today we're going to be solving the simulator workplace assessment for routing and switching. So we're going to be doing the SWA2 Prac. Now, these activities are available on eLearn, so you can just download it straight away and start doing it. Now we do have a simulator workplace assessment number 2 scenario that we have to work with. We do have the network topology, which is already given. It is up to us to basically configure this network. All right, so we do have the scenario. I'm going to read the scenario for you guys really quickly, and then we can get started. Now, just before we do that, can you please confirm to me that you guys can hear me clearly, that the audio is fine, or do I need to make any adjustments? Is that all clear, loud and clear? Yep. All good. So can we just jump in? Awesome. All right. Just pull the chat here, guys. Then I can see your comments at the same time that I'm doing it. All right, let's go. So we do have the assessment scenario. Here's the assessment scenario. ACT Distributed Services has recently hired us as network engineers. So the manager has assigned us a job that requires us to configure, troubleshoot the connections between Reed and Bruce campuses. Each campus has an edge router that uses a lease line to interconnect both locations. The current network topology has also been provided. So this is the one that we have on the right-hand side of the screen. All right. So what do we have here? We basically have one router in Reed campus, another router in Bruce campus. We also have one switch in Reed campus, another switch in Bruce campus. We also have one machine on each campus. All right, so this is what we're going to be working with. And we also have a peer-to-peer connection between these two edge routers of each one of the campuses. So all clear the scenario for you guys. So we do have a serial connection between these two devices. And we also have LANs connected to these devices as well. So let's check it out what we have to do. Your primary mission is to ensure that after you configure and troubleshoot the networks, connectivity between PC1 and PC2 is fully established. Please follow the steps below to troubleshoot and configure the network. So our first step is connect all devices according to the provider topology. As we can see, the devices, they have been already connected. So there's no need to do anything here. I just put this step here because this is what you're going to have to do for the real assessment. The real assessment, you guys are going to have to connect the devices according to the diagram, according to the topology. All right, but we do have to confirm that none of the routers is running an outdated iOS version. So we have a recommendation here, at least version 15, and that they support encryption. All right, so they have to support encryption. Therefore, they need to be K9 and with the latest version of the iOS. All right, so these are the requirements. So in the real lab, we are going to have to do this. So let's just do it here very quickly. Okay, so I'm going to go to the switch. And does anybody remember how do I check the version of the switch to make sure I'm running the proper iOS? In the real thing, you guys are going to have to do this. Make sure the device is compatible with what we're doing here. Yep. I'm going to go show version. And this is going to show us the iOS version. So we're currently running 15.02 SE4 and the iOS image is the LAN base K9. So we have a K9 iOS. We are good to go, everybody. So we do the same for all the other devices in the router as well. Make sure they comply with the requirements. We're running, for the routers, we're running Universal K9, okay? Version 15, so major version 15, minor version 5, 3, okay? Should be fine as well. No issues with this router either, okay? Cool, so we're done. Now that we investigated the devices and that we investigated that they meet the minimum requirements, we are ready to get started, all right? Step number 2, initialize and reload the networking devices according to your supervisor's guidelines and manufacturer specifications. In the real lab, this is going to be crucial for the activity completion, guys. Not so much for this packet tracer, because this packet tracer is already, all the device config has been already erased. So for the packet trace activity, not that much important. But for the real devices, for the real equipment, this is a must, okay? This is a must do for the real equipment. And because of this, we're going to do this here on the devices as well. So the instructions for us on the routers, we are going to erase the startup config and we are going to reload the devices. On the switches, we're going to erase the startup config as well, delete the VLAN.dat, and reload the device. Okay? So please remember this, guys, because once you get into the physical lab, you have to make sure the VLAN.dat database on the switches are completely wiped out. Because if you don't do this, you have issues that you were not expecting. All right? So are we ready to do that? So let's go and do the routers first. So read router, how do I do that? How do I erase the startup config? So to erase the startup config, erase startup config. It's gonna ask us if we really want to do it. We're gonna say confirm, enter, and that's it. Okay? Let's erase the entire config of the router. After we're done with this, it's not enough because we're still running. So we still have running config things. So we also have to reload the device. So reload. It's going to ask us, do you want to confirm? Yes. And that's all we need to do. Is that clear? So we're going to do the same for the other router as well. So I'm going to go router Bruce, enable, erase, startup configuration. So basically cleaning the device before we start, right? And we do a reload, confirm, and that's all. For the switches, there is just one extra step. I'll go to the switch, erase startup as well, erase startup config. And before we do the reload, we want to make sure the VLAN.dat is completely wiped out. Okay. How do we do that? Anybody remember how to delete the VLAN.dat? Oh, that's a good try, but no. Okay, it's delete VLAN.dat. Okay, that's the only difference. When we erase the config. When we delete the database. Done. So we confirm, and that's it. Okay. Now it's telling me that there was an error deleting it because it already didn't exist. So pretty normal because it wasn't there, so it's all good. After we're done with that, we're going to reload the device, and that's all we need to do. So let's do the other switch as well. Enable, erase startup config, confirm, delete the VLAN.dat. Oops. Make sure you get the right spelling. Enter, enter, done. After that, we can reload the device. All good? Clear? Can we move on? So you guys are going to make sure you do this in the real equipment. Okay. Let's move on to the third step. Do the basic device configuration of every single networking device following the requirements below. So pretty much the standard thing that we have to do, the basic device config that we have done on the first assessment. Nothing new here. We can do this pretty quickly. Okay. Now, once again, what am I going to do is I'm going to grab my notepad because I don't like to type it in on every single device, but it's up to you in the end. I'm going to bring my notepad in because I'm going to type the commands in my notepad. All right. So you guys ready to do it? So what I usually like to do is I like to divide my notepad depending on the config of each device that I'm going to be doing. So let's say the switch SW read. Okay, so I'm going to use some hashtags here, whatever, just to divide it. So everything below this line and everything above the next line, I know it's for different switches. So I'm going to do read and groups. All right, so we have to do both. And we also have to do the routers. I'm going to do the same here. So read and groups. All right. All good. Now we're good to go. So let's go ahead and start typing the commands. All intermediary devices, they need to have a host name according to the topology. So for read, let's say we are in user mode. So from user mode, we have to do enable conf t, and then we type it in the commands. So for the host name SW read, and that's all. Okay. First step for switch 1, all good. Next step for switch 1, all intermediary devices, they need to have a banner message of the day configured as secured device get out. How do I do that? Anyone? Type the commands. If you want to participate. No? Come on, guys. You used to be quicker. Banner, MOTD, and then we have to use a delimiter. I always like to use the percentage sign. And what else? Secured, so everything uppercase. Device, exclamation, get out. And then percentage sign again. Alrighty? Now for the domain name, IP domain name, and the domain name, uppercase as well. Okay, cit.net. What's the next step? The console port needs to be secured with an encrypted password that should be password 01. So line con 0 or line console 0. Okay. Now it says here encrypted password. Now in the line we can only type password. We don't have the secret inside the line. So it has to be password. But because we're going to do a service password encryption, that's going to do the job. Okay, it's going to be encrypted anyways. Capital P, password 01. That's it. And then we have to exit the line config with exit. Now there's one extra step for the line. Once we type it in a password, we have to do a login so that next time it's going to be requested. Now I told you guys about this exclamation mark is not going to be read by the device. Okay, So you can use it to make comments. You can use it to divide the commands in a logical order. Up to you. Okay, you can have as many as you want as well. Divide the commands. Okay. Next step. All devices need to be remotely accessible by using a secure protocol that provides encryption. Which secure protocol am I talking about? Which is for remote access. It is SSH. So we are going to configure SSH. Okay. What do we need to do to configure SSH? So you guys remember what we need. So we need to have a host name, which is not the default. We need to have an IP domain. We need to have a crypto key. And we need to have a username password. These are the things we need. So let's go ahead and do the first one. We already have a different host name. We already have a IP domain name. Now we can create the crypto keys or the username first. Up to you. Okay. Let's do the username first. Username. So the required username is Andrew and the secret is Barton. All right. So username Andrew, secret Barton. All right. So that's it. Next line. And then we still need to finish the crypto keys and SSH version, which needs to be set to 2. So how do I do that? I'm gonna zoom in, make it easier. Anyone? Crypto keys, guys. No one? So crypto keys, the crypto key generate RSA, and then we type it in the length of the key. And we are told that we need to set up at least 2048. So we're gonna go 2048 with it. All right. After that, we need to set SSH version to 2. What's the command? IP SSH version 2. Now that we have the username, the crypto key, we have set the SSH version to 2. We have the we have the domain name, we have the host name. We have to configure the line VTYs. Line VTY 0 to 15. How do I set the transport to SSH? You guys are so quiet, mates. Type it in. Yeah? Thanks, call. Transport input SSH will do the job. Okay? And there is one more command I need to type it in so that my SSH request is going to use the username database. What is it? To use the username database that we have. Login local. Perfect. Thanks, you. Login local. And that's all we need to do in the line VTYs. Is that all clear? Let's follow the next few steps. Unused ports. They need to be administratively disabled. And all LAN ports on the layer 2 switches, they need to be protected against rogue devices connected to the port. If a device is connected to a port that has already learned the MAC address dynamically, the port should be put into error disabled state. How do we do that? Now, first of all, we're only going to have to do this on the layer 2 switches. We don't need to do it in the routers. But does anyone know what am I talking about here in this statement? What kind of feature do I need to configure? Anyone? Come on, guys. Yes, port security. That's the feature I'm talking about here. All right. So we have to configure all the ports to be switch port security. And then we are going to administratively disable the ports that are not being used. So let's go ahead and do it. So how do I do it? First, we're going to select all the interfaces. And we can do that with the interface range. All right. Now, what are the ports? So we have to configure port security on all the ports. So F1 all the way to 224. Now, I don't care much about the WAN, about the port that is connecting to the router. I'm more interested in port security for the LAN ports. So that's why we don't need to do it in the gigabit ports. Just the fast Ethernet port is enough, okay? Because these are going to be the ones for the host machines. No need to configure port security on the gig for this activity. You could do it if you wish. Don't have to do it here, okay? All right, cool. So how do I configure port security? Do I remember that? Let's do it together, guys. So what I'm going to do is, let me just save my config. SWA2 Practice. So let's go ahead and do it together. Before we do it together, what I'm going to do is I'm going to take all of this already, which is the basic device config, and I'm going to paste it in my switch. All right? And then we can proceed configuring switch port security to actually try to remember how it works. I'm going to go to my switch read. From here, I'm going to paste my config. Let's see if there's anything that went wrong. Enable, conft, all good, no errors. Host name, banner message of the day, IP domain name, line console, password, login, exit, username, secret, crypto key generate RSA, crypto key was generated successfully, IP SSH has been set to version 2, line VTYs have been configured with transport input SSH, login local to login using the local database. And now we have selected the interfaces that we need to configure port security. How do we do it? Come on, guys. Are you sleeping? No one is saying anything. It's so quiet in here. So quiet. Yes, so it's the switch port security. However, check this out. Yes, okay. A dynamic port cannot be configured with switch port security. That means it has to be an access port. Okay. So what we're just going to do is we're going to make all the ports access ports, and we're going to put them all into VLAN 1. Okay. Because we just have VLAN 1 in this network. Okay. So how do I change the ports to access? Yep. Thanks, DPS. Switch port mode access will do the job. And then to assign it to a VLAN. Done. Okay. So let's go to our TXT because we're going to have to do the same for the other switch. So we did switch port mode access. We did switch port access VLAN 1. What else? Now we're ready to configure switch port security, everyone. Switch port security. Okay. The switch port security alone will activate port security on the ports. Okay. So this is the next one we're doing. Switch port security. Okay. Now we do have to configure a few things. If a device is connected to the port that has already learned the MAC address dynamically, the port should be put into error disabled state. I have to remember a little bit about the theory of switch port security. First, switch port security MAC address. So we can tell the router to learn the MAC address automatically. You guys remember? And then save it even after it reboots itself with the MAC address sticky. And we can then change the violation modes and also the maximum number of addresses. We don't have the maximum number of addresses that can be learned in a port, so we don't have to worry about it. But we do have to tell the router to learn itself the MAC address of the device connected to the port automatically. So we're going to do that with the MAC address sticky. So switch port security, MAC address is sticky. Okay. What else we need to do? If the port is, if there is a violation, the port should be put into error disabled. So you guys remember the violations? Restrict, protect, and shut down. Shut down is going to put the port in error disabled state. Restrict is going to generate a log message about the violation, and protect will not generate anything. Okay, it's just gonna it is just going to identify that as a violation. All right, cool. So we don't have to worry about the maximum, and we don't have to worry about the violation, because the default violation is shut down. But if we were configuring them manually, the commands would be, switch port security, maximum 1, and switch port security, violation, shut down. Okay, so let's keep it in our notepad. So we did MAC address sticky. What else? Maximum 1. And the violation, shut down. All right, are you guys with me? Are you still here? All good? Now check it out. Now I'm inside of the interface range. I have to go back to do all the stuff. Exit, okay? Require an exit as well. All right, so switch port security has been configured, everyone. Our next step, disable domain lookup so that the commands that are not recognized will not take long to be interpreted. How do I do that? Anyone? Yep. Thanks, DPS. So the command for that is no IP domain lookup. Here as well. Are we good? No IP domain lookup. Enable IPv6 routing on the edge routers and set the description on every LAN router interface to be R1 read and R2 Bruce. All right. So what we're going to do is we're going to take this config of the switch. Okay. We're going to have to do the exact same thing on the other devices, except for a few changes. So the entire config of switch read will be applicable to Bruce. Okay. We're just going to change the host name to match. The banner still the same, domain name still the same, password still the same, blah, 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 username, password. Remember, we still need to issue the service password encryption. I'm gonna do it right after the line call. Okay. Same on the other one as well. Are we good? Do it here in the device. All right. Are we good, guys? Still following? Or is it a bit too fast? You want me to slow down a little bit? Oh, man. All clear so far? Stop a little bit here just for other people to catch up with us. All right, can we go? Okay, so we do have the both configuration for both switches in terms of the basic config. We are also going to have to do the basic config on the routers. I'm going to take the same as a template, right? On the first switch that I configured, take all the config, and I'm going to use it as a template for the routers. Now for a router, do we still have enable conft? So this is still applicable. This is still applicable. Hostname still applicable. Banner still applicable. Domain name still applicable. Console still applicable. Service password description still the same thing. Username password still the same. Crypto key generate RSA. IP SSH version. Configuring SSH on the lines. How about the interfaces? First of all, we don't have all these interfaces on the router. And second of all, we are not required to configure switch port security in the router. So I'm just good to go with deleting this stuff. Okay. Name of the device also needs to match read. And that's all. Okay. Now for the routers, remember the two extra steps. We need to enable IPv6 routing and we need to set description on the interface. How do I enable IPv6 routing? How do we enable IPv6 routing, guys? Yep. IPv6 unicast routing will do the job. Okay. So where do you want to do it? I'm going to do it here after the no IP domain lookup. It has to be done in global config. IPv6 unicast routing. Done. Straightforward. Set the description of every LAN interface of the router. So on router 1, it should be read. Router 2, Bruce. Router 1 is the router Bruce. Okay. Router 2 is router Bruce. Okay. Router 1 is router read. So we're going to go to the interface of router read, which is connected to the LAN, which is gig 000. That's the one. Okay. Interface gig 000, 001, sorry. All right. What else? What else, folks? Description read. Okay. I'm going to use this for the router in Bruce as a template. Just going to copy paste it. And let's make the necessary changes. What do I need to change here? What do I need to change here, guys? First step. What else? Anything else I need to change? Yes. Okay, are we clear? So step 3 has now been fully completed. Remember that we're just gonna have to copy the config to the devices afterwards. Not gonna do it now because we still have the IP addresses. Step number 4A, assign the IP address to the interfaces according to the table. SVI of the switches. So on my switch read, we need to create an SVI. How do I do that? And this SVI is associated to VLAN 1. How do we do this? Yeah. Interface VLAN 1. What else? IP address 172.16.1.253 for switch in read. Subnet mask. Done. Okay, what else? I'm gonna do a no shut just in case. And we are done. How about Bruce? Interface VLAN 1. IP address 172.16.2.253, which is the one from the table. 255.255.255.0, which is the subnet mask. What else? No shut, just in case. And that's all we need. Is that right? How about the router interfaces? Let's go to the router interfaces. We already here in gig 001. Okay. We have to assign the IP addresses. How do I do this? IP address 172.16.1.254. 255.255.255.0 as per the table. How about the IPv6? How do I assign IPv6 addresses, guys? And this time they are marked, okay? Because on the first assessment, it was just a preparation for this. Alrighty. IPv6 address, or just ADD. And what is it? You guys want to do the link local first or the GUA first? Up to you. Which one you want to do first? The link local or the GUA? All right, let's do the GUA first. 2001, DB8. So please remember, guys, that in the characters in a hexadecimal IPv6 address, they are not case sensitive. So it doesn't matter if you're doing uppercase, lowercase, doesn't matter. All right, so ACDC, A, column 1/64. How about the link local? How do I assign the link local? IPv6 ADDD, FE80, column 1/64. Link local has to be in front of it. Are we good? Questions, guys, so far? No? Nothing? No questions? For the link local, Nipes, you actually don't need to put it in. No need to put it in. All right. I don't think it's gonna be a problem if we don't put it in. Let me check. Just double check. This is for read. So we're currently doing the read router, yes. So let's see if that's going to be an issue. Yeah, no need to put it in. So for the link local address, no prefix. Okay. All good. Go back. Yeah. All right, let's move on. So we have assigned the IPv6 and IPv6 link local addresses to the interface of the router. What do we need to do next? We have to configure the serial interface. So please remember, we still need the no shut on this interface to bring it up. And then we exit this interface. And then we should be able to go to the serial interface. All right. So I'll give you guys 2 minutes so you can type it in the commands to do this. Type it in. So how do I assign the IP address and the IPv6 address on the serial interface based on the table? Let's go. Type it in the chat, guys. See if you guys get this right. Yep, so for the IPv4, pretty easy. Wrong, you got it wrong. It's 1-1. So 10-1-1, not 0-0. Okay? Be careful with this, guys. Be careful. Okay, pay attention to the address. Otherwise, things may not work as expected. So 1-1-1, yeah, as per the table. 10-1-1-1. And subnet mask. Yeah. All right. And the IPv6 address, just pretty straightforward. 2001 DB8 ACDC B. No, it's not B. Oh yeah. DB8 ACDC. I was looking at the other one. Cafe colon 1 /64. And the link local FE80 colon 1 link local. All right. Are we good? Oh yes, sorry for that. Yeah, my bad. That's a /30. It's a /30 network. Thanks, Nicole. I just skipped it. Okay. So let's double check. So the LAN interface is a /24. The WAN interface, the one connecting to the other router, is supposed to be a /30 because it's a point-to-point, and it is. So now it's correct. Okay. Sorry for the mistake. Sorry, guys. All right, next step. We just have to set up the IP address on the other router. Okay. And remember, we still need to bring this interface up with the no shut. So no shut. Okay. But look at this. There's also an observation here. Choose the router serial interface that will be the DCE or DTE and set the clock rate to 128,000. You guys remember the clock rate is going to be configured on one of the serial points. And we're going to do it in router 1. So how do we configure the clock rate? Clock rate. That's it. 128,000. All right. Don't have to do the clock rate on the other end, just one end. About the router brews, what are the commands? IP address 172.16.2.254 55.255.255.0. IPv6 address is what? That was quickly pass. So 172.16.2.254 and then /24 and the IPv6 2001 DB8 ACDC B column 1 /64, and for the link local address FE80 column 2 link local. All right. No shut to bring the interface up. And that's all. About the serial interface? 0, 1, 0. IP address 10.1.1.2 255.255.255.252. IPv6 address, pretty standard. IPv6 2001 DB8 ACDC cafe column 2 /24. IPv6 address FE80 column 2 link local. No shut. Exit. All right. Now, just to be sure, this interface is connecting to the other interface of the other router. So 10.1.1.2. So the other one, 10.1.1.1. Good. Same network. About IPv6, 2001 DB8 ACDC Cafe 2, ACDC Cafe 1 /64. So all good. FE80 on this link local. FE80 on the other link local as well. One is 2 and the other one is 1. All good. Save my config. All right. Remember that the default gateway address needs to be configured on the switches to enable remote management. Anybody remember how do I do that? Default gateway address on the switches to enable remote management. How do I do this? I'm going to go back to the switches. So for the first switch, IP default gateway. So for the first switch, what's the gateway address of the first switch? Of the read switch? What is it? Come on, guys. What is going to be the default gateway address on the virtual switch interface? Yeah, so it has to be an IP address within the same network, and it has to be the one for the gateway, which is the router interface connected to it. So for switch 1 is going to be 16.1.254, and for switch 2 it's going to be 2.254. Switch 2. Done. That's how we do it. Done. Okay. Are we good? Now we move on to step number 4B. Configure and verify LAN connectivity within site 1 and 2. There won't be any networking personnel on site during the week, and the company is planning to buy new machines soon. Due to this reason, the senior network engineer has told you to configure DHCP. Please look at the DHCP configuration steps from Cisco below and adjust or modify them to suit both LANs. Before we do the DHCP part, guys, what I'm going to do is I'm going to copy paste all the config that I currently have into all the devices and make sure everything I've done so far is working. So for switch number 1, we already copy pasted until here. I don't have to copy paste everything again. I'm just gonna copy paste this part here. I'm gonna go switch read. Check it out. It already has a password, a banner. Okay. I'm just gonna copy paste. Yep, switch port security all good. No IP domain lookup. The interface VLAN, the default gateway, and the switch is up. After that, we're going to copy paste the rest. So switch brute config. All of this up to here. Let's see if everything went fine. Host name, banner, blah, blah, blah. So everything is fine. Okay. Now we're going to do for router read and router bruise. Router read. Take all of this and dump it into the router. Make sure everything is fine. Crypto keys, banner, all fine. SSH, interface. Interface is now up. Cool. Router bruise now. I'll say no to this. Paste. And we are good to go, everybody. Everything's going green at the moment. I can use the fast forward button. Everything is beautifully green. All right. Now we still have to deal with the IP addressing. So we still have to configure DHCP. This is exactly what we're going to do now. All right. Everybody ready? Are you guys all up to here as well with me? Yeah. We're nearly done. The rest is pretty quick. So because there won't be any person to statically assign the IP addresses to the client machines, we are going to configure the routers to give IP addresses to the LANs. We're going to configure the DHCP on the routers. How do we do that? So I'm giving you guys the step, okay, the step-by-step guide. First, we exclude static addresses from the pool that are already being used. We then create the pool, configure the network, configure the gateway, and if necessary, the DNS. We don't have any DNS server. We don't need to specify it in this activity. So let's go ahead and configure it. So I'm going to do router read first. We also have some instructions. So your supervisor has stressed that due to lack of Windows Server on each site, every edge router to each site needs to automatically assign IP addresses to the client machines. After making the necessary adjustments to the command above, please record the commands that you entered on each router. Because you have that's a completely different stuff. So it's up to here for the DHCP. All right. So it also tells us that the name of the pools, they should be this, and to exclude the first and the SVI in the network. So let's go to router read, and the first step is to exclude the addresses. So we're gonna go, okay, so we do exit to go back to global config. I'm gonna put it here as well. In my router read, I did an exit. And now how do we configure the DHCP? First step, exclude the addresses. So what's the command for DHCP? Does anybody remember? Yes. IP, DHCP, right? Let's look at the options. Exclude address, create the pool, or configure it to relay. Send it to a different server, the requests. So excluded address, because we need to exclude certain addresses. So it's telling us to exclude the first available in the network, which is 1, and to exclude the SVI. What's the SVI of the switch? "253", isn't it? Done. So we exclude the first available, and we exclude the SVI. All right. Are we good? I'm going to type it in here in my notepad as well, so I can remember what I'm doing. So we excluded the first, and we excluded the SVI. Now we are ready to create the pool. How do we create the pool? IP, DHCP pool, and then we assign it a name. The name is given. So for router 1 is LAN 1. It's going to be giving addresses for the local area network number 1. And now we are inside DHCP configuration mode. Inside DHCP configuration mode, we can specify the default gateway, which is the same as default router. We can specify the DNS, the domain name if we have one, the exit to leave the configuration of DHCP, the network to specify the network of addresses, and options if we have any. So given what I have here, the first step is configure. After we exclude the addresses, create the pool. We already created the pool. Configure the default gateway. So default router. What's the default router for this network? Okay, it's the interface of the router connected to the LAN. What else? The network 172.16.1.0, and the subnet mask is 255.255.255.0, and that's all. All right. All we need for this router. Seriously. We don't need DNS because we don't have any. After this, we go back. Okay. Write it down in my notepad. So after excluding the addresses, IP DHCP pool, LAN 1, all right, default router, set up the default gateway address. the network. Oops. And that's all. All right. Now you guys are going to help me out. Based on this that I did for read switch, the read router, what do I need to change to make it the same for the Bruce router? I need to change the excluded addresses because now they are in the 2 network. And I need to change the pool name because it's now LAN 2. The gateway is also different. And the network, which is not 1 anymore, it's 2 in the 3rd octet. All right. Can even copy and paste into my Bruce router. Done. Both of them are now operating as a DHCP server. Cool. How do I check? I can go to the PCs, desktop ipconfig, DHCP, and check it out. What happens? They obtain an IP address. All right. Exactly. The same thing goes for the other segment of the network. And that's it. Alrighty. So we're done with the DHCP. Now it's a matter of configuring the access lists. So because you've been hired, you want to go the extra mile, show your manager you can also make decisions that can improve security. So you'll be setting up a standard ACL to restrict, it's actually extended. So this is misspelled. An extended ACL to restrict SSH and allow host machine with IPv4 addresses of 172.16.100 to manage the switches. Modify the standard name access list below to perform this. So I'm giving you the commands. You just have to modify them. That is it. Okay. How are we going to modify this? Go ahead and do it. So first of all, we are configuring the line VTYs to restrict the access. Okay. I'm going to do switch read first. Password 01, enable conf T. All right. Now let's go ahead, guys. First step, we're going into the line 0 to 15. Next step, we are going to assign access control. So the command is access class. I'm giving it to you. Underscore access. Okay, in. This is how to configure it. And then we're going to leave this and we are going to create it. How do we create it? IP access list extended SSH underscore access. And then we are going to type it in the permit. So this is the source IP. This is the destination IP. The source is going to be the machine with IP address 172.16.100. And the destination is going to be the IP address of the SVI. So it's going to be permit TCP host 172.16.1.100 all the way to 172.16.1.253, which is the SVI. Oops, forgot the host. And EQ22, so equal 22. This is the port number. Port number for SSH is 22. And then we click enter. And that is all. And we can go back, exit, and that's all. Okay, very straightforward. I'm going to type it in my commands. Where is that? Router 1. So everything we did, we went to the line VTY 0 to 15. We did access class, SSH access. So we're basically restricting the access to SSH to a specific IP. Exit, IP, access list, extended SSH underscore access. Permit TCP host. Yeah, that's for the switch. Sorry, Nipes. I'm just gonna grab this. Thank you, Nipes. The switch. I want to restrict the access to the switch. Access class, exit, IP access list, exit. Okay. And we are good to go. So I'm gonna copy, paste, and use this for the other switch. What's the difference here? That what do I need to change to make this suitable for the other switch? The IP address of the SVI. Okay, because now we are controlling access to the other switch. So I'm gonna copy paste this in the other switch. And we are done. Okay. SSH has been now configured. Our next step is configure WAN connectivity between sites 1 and 2. So this is where our static routes will come in handy, okay? The routers, they only know about the interfaces directly connected to them. So right now, if I wanted to ping from PC read to PC brews, this is not going to work because once the ping goes to router read, it's gonna get dropped because router read doesn't know how to get to the SW brews network. Having said that, what do we need to do? We need to create a few static routes. Okay, so in router read, which is R1, we are going to type IP route. So if this static route is using the exit interface, guys, how is it called? It's a review of yesterday's lecture. It's called a directly connected, yes. What's the alternative for a directly connected? What is the alternative? Yes. Okay. So in here, we are using the exit interface. Okay. Oh, this is actually not the right one. It's misspelled. This is supposed to be serial 010, guys. I'm sorry, I found the error. So this is not supposed to be 000. It's supposed to be 010. Okay, because we don't even have 000. I'm just gonna remove it. Okay. Yeah. IP route 172.16.2.0. And how do we get there? We get there using this interface. Now it's the correct one. Okay. I'm gonna fix this, guys. Sorry. My apologies. I'm gonna release the version 2. In the version 2, this will be fixed. Alrighty. What's the next one? We also need to configure an IPv6 static route. IPv6 route 2001 DB8 ACDC B column 1. What else? /64 and the exit interface 010. All right, done. That's all we need. And am I going to be able to ping it now from PC read to PC brews? Why? Why am I still not able to ping? Because there is no way back. So we have to configure our way back. And how do we do that? Configuring the static route in the router brews. How do I do it? IP route. Now it's the other network that I'm interested in. The 1.0.1.0 and IPv6. All right. Before you attempt this test, make sure your DHCP is working. So make sure you can verify the client machines, blah, blah, blah. Yep. So we do have some theory questions for you guys to answer still. We're still not at the 100% mark. Let's find out why. Might be some typos, some mistakes. I'm gonna show incorrect. We didn't set the crypto key in the router brews. That's weird. And it's saying that the IP interface on the router brews is wrong. Let's double check that. On router brews, do show IP interface brief. 10.1.1.2. Maybe the subnet mask. Do show run section. Yeah, looks correct. Router brews 10.1.1.2 up there. Subnet mask seems to be correct as well. About the IPv6 interfaces, are they correct? ACDC Cafe 2 and yeah, it's correct. Let's see what else. The crypto key generate RSA. I thought we did this in router brews. Crypto key generate RSA. Yeah, it's here. I'm gonna repeat this command in router brews. I'm gonna replace it. Yeah. 2048. Yep. Yeah. It's just a problem with the marking, guys. It's correct now. I'll fix it. I'll fix this. And the reason why this is incorrect is because of this. So in the instructions, go back to the instructions. In the instructions, it actually tells us to exclude the first and SVI. This was supposed to be exclude the last and the SVI. Okay. So that's the mistake. So when I did the answer, I used the last. So we can fix that. I'm going to modify the file, so don't worry about it. But if you want to fix it, you just have to go into the no IP DHCP excluded. So we are not excluding the first one. We are excluding the last one instead. The 254. Okay. So this should fix the issue with the IP address. On router Bruce as well, if we do this modification, that should fix the issue as well. So no IP DHCP excluded 172.16.1.2.1. We're going to replace it by the last, removing the last. Okay. So this should fix the issue with the IP address of the host machines. If I click on the PC and if I try to obtain an address again, I'm going to obtain the first one. Okay. For both of them. Yeah. All right. What else is missing here? It says the default gateway on the devices are incorrect. Okay, on the PCs. Let's have a look at why. So with the DHCP, the gateway being given is 172.16.1.254. Okay, which is the correct gateway. All right. So it's all good here as well. I'm gonna fix that as well. All right. But this is all you guys have to do. I'll just fix that because when I released the activity yesterday, I didn't do the final review properly. I'm going to fix this right now. But now you guys know how to solve the activity. Okay. Any questions, guys, in regards to anything like this? Anything about the activity itself? I'm just going to fix these few bugs and I'm going to release the version 2 of the activity. And you guys should be on your way.